Vocabulary of the day, least common multiple. This is something you reviewed in 7th grade and hopefully also in 5th and 6th grade. It's similar to least common denominator, except we are not working with fractions. Least common multiple is defined as the smallest number that two or more numbers divide into evenly, not to be confused with greatest common factor. So least common multiple, if we were talking numbers only and we had the number 3 and the number 6, the least common multiple would be 6. We're in 6.4 today. Solve linear systems by multiplying first. And that is our goal of the day. To do so, we're still going to eliminate, but before we can eliminate an x or a y variable, we're going to have to multiply by a number other than 1 or negative 1. So it's building upon everything we learned in 6.3 and taking it to the next level. We have these examples. They're in your book after example 1 and 2 under guided practice on page 394. So if you look today, we have two equations, 6x minus 2y equals 1, negative 2x plus 3y equals negative 5. The first thing we want to check is that they're both in the same form. And in this occasion, they are x, y, x, y. So now that we have them in the right form, we want to look for opposites. And as you can see, there are no opposites. We're going to have to make opposites. So to do so, we're going to leave the first equation alone, but we're going to look at the second equation, and we're going to multiply it times 3. And when we do, 3 times negative 2x, negative 6x, 3 times 3y, plus 9y, and 3 times negative 5. Now we have our new second equation. Here is our original first equation. And if you look, we have created opposites, negative 6x and positive 6x. So if we go to combine these, negative 15 and 1 would be negative 14. Positive 2y and, positive 9y and negative 2y leaves us with 7y. And negative 6x and positive 6x would be our 0. We solve this by dividing both sides by 7. So the value of y is negative 2. We're going to take that back and substitute into either of our original equations. I'm going to work with the first. 6x minus 2y equals 1. Remember, always go back to your original equations. 6x minus 2 times minus 2 equals 1. 6x plus 4 equals 1. If we subtract 4 from both sides, 6x equals negative 3. Now we divide both sides by 6. The value of x is negative 3 over 6, or in its best form, negative 1/2. So we have our final solution, a coordinate point, negative 1 over 2, negative 1/2, and negative 2. In this example, we have 2x plus 5y equals 3, and 3x plus 10y equals negative 3. Let's leave the second equation alone, and let's multiply the first equation times negative, oops, my mistake, not times negative 5. We want to multiply the first equation. We have a positive 5. We're trying to get to a negative 10, so we want to multiply by a negative 2. So negative 2 times 2x plus 5y equals 3. Negative 2 times 2x, negative 4x. Negative 2 times 5y, negative 10y, and negative 6. We multiplied everything times our negative 2. I'm actually going to get rid of this parentheses here. It should have been on the outside. So now if I rewrite my original equation, the second equation as it appeared, 3x plus 10y equals negative 3. We can see that we have created opposites. We can combine. Negative 6 and negative 3 would be negative 9. Negative 10y and positive 10y is 0. Negative 4x and positive 3x would be negative 1x. So we have negative x equals negative 9. We want to know what positive x is, so we divide both sides by a -1, and we end up with x equals 9. Once we have that, we substitute it back into either of our equations. I'm going to work with the first equation, 2 times 9 plus 5y equals 3. 18 plus 5y equals 3. Subtract 18 from both sides. 5y equals -15. Divide both sides by 5. Y equals -3. So our coordinate point is 9, -3. Problem number 3, if we look carefully, we have 3x minus 7y equals 5 and 9y equals 5x plus 5. The first thing we need to do is get them in the same form. So I'm going to look at the second equation, 9y equals 5x plus 5. I want to make it look like my first equation, so to do that I need to get this 5x over here. I subtract 5x from both sides. I now have -5x plus 9y equals 5. Here was my first equation, 3x minus 7y equals 5. I don't have any opposites. I don't have a way to just multiply one of these equations, so I'm going to have to multiply them both. And if you look carefully, if I take the first equation and I multiply it times 3, and I take the second equation and I multiply it times 5, it looks like we can end up with opposites. So let's do that math. 3 times -5x, -15x. 3 times 9y, 27y, and 3 times 5 is 15. 5 times 3x would be 15x. 5 times -7y would be -35y, and 5 times 5 would be 25. We have created our opposites, so we can eliminate one of our variables. That would be our x. 15 and 25 would give us 40. 27y minus 35y, -8y. And again, this is 0. If we divide both sides by -8, the value of y is -5. So if we take that value, substitute it in up here, 3x minus 7y equals 5. 3x minus 7 times -5 equals 5. 3x, -7 times -5 plus 35 equals 5. We're going to subtract 35 from both sides. 3x equals -30. And I actually wrote that wrong. Let me fix that real quick. We're subtracting 35 from both sides. Whatever I do to one side, I have to do to the other. Now I subtract and have 30. Now I'm going to divide by 3. And the value of x is -10. So my answer, again, a coordinate point, -10, -5. This is a table in your book. It's a great reference. We've now learned a multitude of ways to solve a system of linear equations. At some point, that becomes your option, your choice. Not today. Today we are multiplying first. But when it does become your choice, this table gives you a hint as to which method works best. And that is in your book on page 396. Your assignment today is 3 through 12 on page 396 to 397.